Hey, Miss Marion here. We are actually doing Unit 7, Lesson 10 and 11. But first of all, we're going to do some starter questions, getting us ready for the end of level tests. Go ahead and get a piece of paper. Let's find the slope and the y-intercept for the following graphs. So go ahead and pause, answer that question, and then come back to me. All right, let's go ahead and find our slope and our y-intercepts. Remember, our slope, we like to do our vertical over horizontal, and we're going to make a slope triangles. So my vertical is 1, horizontal is 2. So my slope for number 1 is 1 over 2. Next, let's go ahead and figure out our y-intercept. So remember, the y-intercept is where the line crosses the y-axis. The y-axis, remember, that is this one here. Where is this y-intercept? That y-intercept is at 0. So our y-intercept is equal to 0. All right, let's go ahead and let's figure out for number 2. So again, our slopes are verticals over horizontals. So we want to go ahead and draw a slope triangle. So my vertical is 2, horizontal is 2. So we have 2 over 2. Oh, and the other thing we need to figure out is a line going up the hill or down the hill. And this line is going down the hill, so it's going to make it negative. But you also need to reduce the fraction down as simple as possible. So we're going to have negative 1 over 1 as our slope. Again, where does the line cross the y-axis? That's here. So that's 1, 2, 3. So our y-intercept is at negative 3 on the y-axis. All right, number 3, again, our slope is our vertical over horizontal. And again, we're going to draw our vertical and horizontal. Vertical is 1, horizontal is 2. And is this going up the hill or down the hill? It's going up the hill, so it's going to be a positive 1/2. Y-intercept, remember, that's where the line crosses the y-axis. So that's 1, 2, 3, 4. So the y-intercept is negative 4. Number 4, again, we're going to find our slope, which is vertical over horizontal. So we have vertical, horizontal. Vertical is 1, 2, 3, 4, 5. Horizontal is 1, 2, 3, 4. So our slope triangle is 5 over 4. Is it going up the hill or down the hill? This is actually going down the hill, so it's going to be negative 5 over 4. And we're going to leave it as an improper fraction. I do not want this as a mixed fraction. I want it as improper. Moving on, let's find the y-intercept. The y-intercept is where the line crosses the y-axis. So the y-intercept is negative 2. All right, let's do our last one. Last one's a little bit trickier. And so we want to find our slope, which is our vertical over horizontal. So I have my horizontal. My vertical is actually 0. Horizontal is 1. Grab your calculator. Let's do 0 divided by 1, which is 0. So it's not none. 0 is a number. So our y-intercept is 0. Where does the line cross the y-axis? That crosses it at negative 1. So our y-intercept is negative 1. All right, so let's go over so a little bit of review, okay? And so we're going to kind of figure out some other stuff on here. And so last lesson, we should have learned that we can go ahead and write different things different ways. So we have this huge number, right? And we write it as 150 times 10 to the 9th. There's another way, so it's a power of 10, right? And we can also write it where, so we kind of go from the decimal point, I guess you can kind of say it that way, and 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is where the 9 comes from, here, okay? So what if we actually put it a little bit further? and we moved it to 15. So it would be 15 times 10 to the 10th. If you add them all together, there's 10 places, right? And then also we can make it so that it's going to be here, which will be 1.5. And how many decimal places would that be? That would be 11. So notice this is a really big number, and it's going to have a positive exponent, and there's different ways we can write that. Let's look at the light of speed, or speed of light, sorry. And so again, our decimal points at the end. Let's count how many. 1, 2, 3, 4, 5, 6, 7, 6, right? Sorry. That's where we get this one from. So we can actually extend out a little bit more. We can do the 7, right? So we can say 30 times 10 to the 7th. And then we can actually even move it over even further and make it 3 times 10 to the 8th. Again, this is a really large number, and it has a positive exponent. Now let's talk about decimals. The decimals, all right, so a number between 0 and 1, decimal kind of thing. Notice how it has a negative exponent. Still, like the same kind of thing that we did before, we can count how many decimal places. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's why we have and it's negative 13 because it's a small number, so it's a decimal between 0 and 1. It makes it a negative number. So let's kind of move it so that the decimal is here. So if we actually counted that again, we'll actually count so that it's 4.8 times 10, and it's actually 12 decimal places. So know how it kind of changes on that. And then if we really wanted to do it, we can actually make it so the decimal point's in front of the 4, so 0.48, and that would be times 10 to the negative 11. And again, it's negative because it's a small number. It's a decimal between 0 and 1. Let's try the last one, mass of a proton. So again, we can go ahead and we can start and we can count all the way over here. And if you actually count all of those decimal places, we do get that 29. And again, it's negative. It's a negative exponent because it's a number between 0 and 1. It's really, 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 really small, right? Because it's a proton, okay, part of the masses of cells. And again, we can go ahead and we can move it so that it's here. And we say it's 16.7 times 10 to the negative 28. We can actually count how many decimal places there are, and there's 28 of them. And then we can also make it so that it is 1.67 times 10 to the negative 27, because you can, and that would go here, right? And then we can also make the decimal point in front and make it so it's 0.167 times 10 to the negative 26. So notice how there's different ways we can do it. And I actually forgot up here that we can actually make them so that the decimal points kind of go in front. So we can say it as 0.15 times 10 to the 12th. If you count how many decimal places, it would be 12. And then on this one, I can do it as 0.3 times 10 to the, count them all up, 9. So notice how there's different ways, but notice how the exponents change depending on how many decimal points there are. Now, since we have a review of what we did on Friday, go ahead and turn your workbook to page 131. We're going to read 2 lessons worth of stuff. It's a lot of I-can statements. Lesson 10 is, I can rate a large number as a multiple of a power of 10. I can plot a multiple of power of 10 on such a number line. And I can subdivide and label a number line between 0 and power of 10 with positive exponents into 10 equals intervals. A lot of stuff. Write yourself a sentence, how you feel about it, and a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And 4, I can teach it to my friend. Still stay on that page, and we're going to read lesson 11. I can write a small number as a multiple of power of 10. I can plot a multiple of power of 10 on such a number line. And I can subdivide a label and the number of line between 0 and the power of 10 as a negative exponent into 10 equal intervals. So we're going to be cover a lot of stuff. It's actually going to be quite short, but we're still covering a lot of stuff. Give yourself a sentence Also, giving yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And then 4, I can teach it to my friend. All right, lesson 10. Let's go and turn back to page 73. It says, label the tick marks on the number line. Be prepared to explain your reasoning. So there's different tick marks. So notice how it starts here at 0 and goes all the way up to 10 to the 7th. So go ahead and label the tick marks. Think about what you think it would be, and then come back to me. So pause, do that, and then come back to me. All right, there's different ways you can actually label this. And how did I decide to label it? I'm going to say this is 1 times 10 to the 6, 2 times 10 to the 6, 3 times 10 to the 6, 4 times 10 to the 6, 5 times 10 to the 6, 6 times 10 to the 6, 7 times 10 to the 6th, 8 times 10 to the 6th, and 9 times 10 to the 6th. I just noticed there were 10 marks there, so why not kind of bring it through that? Did you have to label it this way? No, it's getting us ready with number lines and powers of 10. All right, turn to page 73 to 74. We're going to do, so the number line is on page 73, the information is on page 74. So I decided to put it together for you, okay? So 1, we are going to place the numbers on the number line. Be prepared to explain your reasoning. So kind of like what we did in our warm-up starter question. And then we're going to go ahead and we're going to place all of these points on the number line. And then eventually we're going to look at it and see what our friends did. Okay? So go ahead, pause, answer that question, and then come back to me. All right, so here are the points that I plotted on my number line, and I want to go ahead and go through this so we understand what it actually is. So I noticed there were a lot of them where it's like 10 to the 6th, 10 to the 5th, 10 to the 5th, and 10 to the 7th. This number is not with times 10 to whatever. So we're going to use the information that we learned in the last lesson, and we're going to write it as 4 times and then 10. So notice how we start from the end where the decimal point should be. So it's 1, 2, 3, 4, 5, 6. So this is 4 times 10 to the 6th. Okay? And then I have 5 times 10 to the 6th, 5 times 10 to the 5th, 75 times 10 to the 5th. Well, all the other numbers, notice how the other numbers up here, they have whole numbers and they have whole number stuff. This is 75, right? So I'm going to actually change this one, and it's going to help me out. So I'm going to actually change it. So I still want times 10 to something. And I know the decimal point is here, and I'm going to move it over kind of once more. And so I'm going to have 7.5. And I learned on the last lesson that if I actually had all the 5 zeros counted up there and I added one more decimal point to it, it would make it times 10 to the 6th. And then I'm going to do the same thing down here, but this is a negative exponent, right? Well, not a negative exponent, but it's a decimal, right? And so I want to figure out how to go ahead and write this one. And notice how it kind of went from a decimal to a bigger number. And I learned last lesson is kind of pretty much kind of taking off one. So up here, we added one onto it. And then here we're kind of taking off one because of the negative stuff, because it's a decimal. So this is going to be 6 times 10 to the 6th. So notice how up here I have the 5 times 10 to the 5th. Here is the 4 million, right? But that's also known as 4 times 10 to the 6th. Next, I have the 5 times 10 to the 6th, because that's a little bit bigger. This one here, it's 0.6 times 10 to the 7th. But remember, that number is actually 6 times 10 to the 6th. And then up here, I have 75 times 10 to the 5th, but that number is also known as 7.5 times 10 to the 6th. And then those are all my points that are labeled on this line. So looking at our numbers that we have, which one is larger, 4 million or 75 times 10 to the 5th? So look at that, figure out which one's larger. If we put it on the number line and we want to go ahead and look at it, 75 times 10 to the 5th, or the same as 7.5 times 10 to the 6th, is about twice as large as the 4 million, which is also 4 times 10 to the 6th. So that's why the 75 times 10 to the 5th is bigger than the 4 times 10 to the 6th. So in our next activity, we're going to be talking about the speed of light. So the speed of light is this huge number, right? So we need to think about how to kind of put this on a number line itself. So if I was actually going to go ahead and label these tick marks, we can label them different ways, right? So if this was actually put in as like a power of 10, it would be 3 times 10 to the 9th power, right? So I could label this as 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6, 10 to the 7, and then 10 to the 8, and then 10 to the 9th. So we'd actually put this information on a number line. So let's kind of keep this in mind while we actually go through everything. So if we look at page 74 to 75, we have this table, and it shows how fast light waves or electricity can travel through different materials. Okay, so we have the speed of light, we have space, water, copper, wire, diamond, ice, and then olive oil. So which is faster, light through a diamond or light through ice? And then how can we tell from the expressions on here? So go ahead and look at that, answer that question, and then come back to me. All right, let's go ahead and let's look at this. So we're looking at diamond. A diamond is here, right? And I have it 124 times 10 to the 6th. But I want to make it so that it's, well, we're doing diamond and we're looking also at the ice. Ice is this number down here. And notice how it has times 10 to the 8th. But notice how it's just 2.3, 10 to the 8th. This is 124 times 10 to the 6th. So I want to make them so I can compare them a little bit better. So let's go ahead and let's take the decimal and put it here. So it's 1.24, because notice how the front numbers are now closer. So they're numbers between 1 and 10, right? And this is going to be times 10 to the 8th power. So which is faster? Actually, the light is faster through ice than it is through the diamond, because if we compare those two numbers now with the same exponent, the 2.3 is faster than 1.24. All right, so let's look at it a little bit further. So label the tick marks between 2.2 times 10 to the 8th and 3 times 10 to the 8th. Plot a point for each speed and both number lines and label it with the corresponding material. There is one speed that you may not write it in the number line. So notice how we kind of have this bigger number line, and then we have the middle one expanded out. Okay, so we kind of zoomed it in and zoomed it out. And you're actually taking the table and you're going to plot them on these points in the different areas. Okay, so go ahead and pause, answer that question, and then come back to me. So here is the answers of where you should actually go ahead and should have plotted those points. Notice how the diamond is 1 times 10 to the 8th. And it actually wasn't in the middle in here because it's 1. And it went from 2 times 10 to the 8th to 3 times 10 to the 8th. So we kind of see like the normal number line and then like the zoomed in number line with the oil, water, ice, copper, and then the space itself. So now let's look at number 5. Which is faster, light through ice or light through a diamond? How can you tell from the number line? Okay, so let's look at the number line itself and answer that question. So if we want to go ahead and look at the number line, we already kind of know it's ice. But now if we look at the number line, here is the diamond and then here is the ice. And that ice one is actually like right here, right? So again, we've shown that ice is faster, light goes through ice faster than it does with the diamond. So what are ways that we can come up to write this big old number here, right? What are ways we can write it? If we want to take the decimal point and move it, so it's here. So how many is it? The 1, 2, 3, 4, 5, 6, 7. I could write this as 23 times 10 to the 7th. Ooh, I could write it as 230 times 10 to the 6th, because that kind of brings it like right here, right? And I can also write it as 2.3 times 10 to the, let's count it, 1, 2, 3, 4, 5, 6, 7, 8. And what if I brought it all the way to the front as 0.23? It would be times 10 to the 9th. Notice how all of these different ways of doing this number, they're all different, but they're the same number. And then what are ways that we can come up to find the value of 5.4 times 10 to the 5th? We can think about how big that is. We can put it in our calculator right now. It will actually show us, but after that, if it gets a little bit bigger, sometimes our calculators don't do that. So we can kind of think of it on a number line. If I put it on a number line and compared it to another, then we'll actually understand it. So now we're going into lesson 11. So go ahead and turn to page 81. Kieran drew this number line, and then Andre said, that doesn't look right to me. Explain why Kieran is correct, or explain how he can fix the number line. So go ahead and pause, answer that question, and then come back to me. All right, so what's wrong with this? Well, let's think about number lines themselves, just normal number lines, right? So we have 0, and then we'll have 1, and then we'll have 2. And we have -1, -2, -3. So did Kieran actually set this up correctly? He didn't. Notice how it's -5, and then it goes to -4. So all these in here should actually be like -6. Because if we follow a normal number line, negatives go backwards considering what we want it to do. So all these should be -6. All right, let's turn to page 81 to 82. Here we have a number line. Label the tick marks on the number line. And then after that, go ahead and plot all of these points on that number line. So go ahead and pause, do that, and then come back to me. So let's talk about actually just labeling the number line. So notice how we have 10 to the -5 here. So I'm going to kind of work backwards until we go ahead and get to the 0 part. So it's kind of, again, it's backwards considered what we think it would be. So this first one can be 1 times 10 to the -6, 2 times 10 to the -6, 3 times 10 to the -6, 4 times 10 to the -6, 5 times 10 to the -6, 6 times 10 to the -6, 7 times 10 to the -6, 8 times 10 to the -6, and then 9 times 10 to the -6. So remember, this is kind of flipped as far as how we normally read this kind of stuff. And remember that having times 10 to the -6, that's a decimal. That's a decimal really small. So it's kind of backwards as far as it goes from 0 all the way to 10 to -5. It's not on a number line 5. It's actually a decimal 5 kind of thing. So kind of keep that in mind. Now, knowing how we actually label it, go ahead and plot A, B, C, and D onto this graph. All right, so here is A, B, C, and D itself. Okay, let's kind of go through it. A and B are pretty much kind of the same stuff. Those are actually kind of easy to go ahead and put up here. Notice how this is 29 times 10 to the 7th. I don't really have a times 10 to the -7, but I can go ahead and move that decimal, right? Remember, we've been kind of doing that. And I can move it so that it is 2.9 times 10 to the, and then it kind of goes down because it's a negative. There's not as many decimals in there as far as decimal between 0 and 1, okay? And then the other one, I can move it here. So then we have 7 times 10 to the -6. So we kind of have to kind of wrap our mind around that as far as how those kind of change and don't change. All right, let's look at 3 and 4. Which one's larger? 29 times 10 to the -7 or 6 times 10 to the -6. And then estimate how many times larger, okay? And number 4, which is larger, 7 times 10 to the -8 or 3 times 10 to the -9. Estimate how many times larger. So let's kind of think about those and then estimate along with it. So go ahead and pause, answer that question, and then come back to me. So again, I like to go ahead and I like to kind of make it so that the decimals, so the exponents on these numbers are actually going to go ahead and be the same. So I'm going to go ahead and I'm going to make the 29 a 2.9 times, and then remember it kind of goes downward in a way as far as we're missing, like it's a 29 and then going to 2.9, and it kind of changes it just a little bit as far as those decimal kind of stuff. So now I have 2.9 times 10 to the negative 6. I have 6 times 10 to the negative 6. And I'm going to think of this one, so I'm going to just kind of estimate it for a second. So it's about, that's what these squiggly lines are, 3 times 10 to the negative 6. And then I have 6 times 10 to the negative 6. So, it's how much times bigger? Well, yeah, it's kind of about twice as big, right? So if I take the 2 and try to make it a 6, it's times 2. And then 10 to the negative 6 and 10 to the negative 6 is the same. So it's about twice as big. And the this one is bigger, right? Okay. Let's look at number 4. So again, with number 4, I like to make it so that the exponents are the same. So let's go ahead and think about it as far as the different exponents. But also, I have a 7 in the front and then a 3 in the front. So really, I am comparing the 10 to the negative 8 and then 10 to the negative 9. So which one is actually going to be bigger? So remember, okay. So negative exponents, and it's a decimal. So if you have a lot of decimal places, that makes it smaller. And if you have shorter amount of decimal places, that makes it bigger. So which one is bigger? Well, that's going to be the 7 times 10 to the negative 8. That one is bigger. Now, let's go ahead and compare it. Okay, so I want to go ahead and figure it out. So I'm going to think the 7 as just as a 6, like 6 times 10 to the 8th, negative 8, okay? And then we have it, the other one is 3 times 10 to the negative 9. So to go from a 6 to a 3, I know it's going to be 2. And then notice how there's kind of like a decimal place that's different between. We have negative 8, which is bigger, because how many decimal points are there, compared to negative 9. So it's going to be about 20 times bigger than the other. All right, let's go ahead and move on. Let's look at page 82 to 83. We're going to look at number 1. It says the radius of an electron is this huge decimal kind of thing. Write this as a multiple of power of 10, okay? So, okay, we can do it different ways. And then think about it. We're eventually going to put it on the number line too. So go ahead and decide how it's going to be a power of 10 and then come back to me. Let's talk about that first before we put it on the number line. All right, so the way that I like to put these into a power of 10, I like to put the decimal point after the 3. So I'm going to have it as 3 times, and then how many decimal places are there? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I know it's going to be times 10 to the 13th. And then remember, that's a decimal. And it's a decimal between 0 and 1. So that's going to have a negative exponent. So this number for the radius of an electron is 3 times 10 to the negative 13th. So know how a lot of scientists actually use these numbers, because if I try to write that down over and over and over again, I might miss one of those zeros and actually get it off. That's kind of like that quiz question that we had the other day. So we use these kind of different ways of writing numbers, of really big numbers and really, really, really small decimal numbers. We actually use the times 10 or a power of 10 kind of stuff. Okay, so now we decided to go ahead and write it as 3 times 10 to the negative 13. So now we need to go ahead and we need to label our number line. So since we're dealing with 3 times 10 to the negative 13, I'm going to actually, and we can label it different ways, but I'm going to say that this is 1 times 10 to the negative 13. And then we have 2 times 10 to the negative 13. 3 times 10 to the negative 13. 4 times 10 to the negative 13. 5 times 10 to the negative 13. 6 times 10 to the negative 13. 7 times 10 to the negative 13, 8 times 10 to the negative 13, 9 times 10 to the negative 13, and then this is like 10 times negative 13, but let's think about that. So that's actually kind of going to be a bigger number than what it has, which actually makes it smaller decimals. So that's actually going to be labeled as like just 10 to the negative 12. Yes, the decimal stuff is a little bit different than what we thought, but yes, it's going to be 10 to the negative 12. All right, the C part of this, let's go ahead and take the radius of electron and we're going to plot it on our number line. Well, where would that go? That would go right here, 3 times 10 to the negative 13. So did you have to label your number line this way? No. It actually, this is actually a closer view into a normal number line. And as far as if we did it a different way, it would actually make it really, really kind of harder to see, because sometimes we'd have to plot them kind of within here really, really, really close. So then I decided to go ahead and go from 1 times 10 to the negative 13 all the way up to pretty much the 1 times 10 to the negative 12. And so it makes a closer look into that number line. All right, number 2, the mass of a proton. Oh my goodness, look at that decimal. All right, so we're going to decide, we're going to write it as a power of 10. And then again, we're going to go ahead and label this, and then we're going to also put that point on there. So go ahead and do number 2, do all of it this time, and then come back to me. All right, did you count all those decimal places? I did. So what did I come up with? I'm actually going to put my point here, because I like the first number to look at is kind of like a number between 1 and 10, that my brain can actually wrap around that. And then all I had to do is count how many decimal places. So it's 1 times 10, and there's 24 decimal places, and it's negative 24 because that's a small decimal. Well, okay, it has a lot of decimal points. It's a number between 0 and 1 with decimals is really what we're looking at. And there's 24 of them, and so it's going to be negative, right? All right, so let's go ahead and let's label our number line, okay? And you can label it different ways. I'm going to do kind of like I did before, 1 times 10 to the negative 24, 2 times 10 to the negative 24, 3 times 10 to the negative 24, 4 times 10 to the negative 24, 5 times 10 to the negative 24, 6 times 10 to the negative 24, 7 times 10 to the negative 24, 8 times 10 to the negative 24, 9 times 10 to the negative 24, and then our last one is pretty much 10 times 10 to the negative 24, which really makes it 10 to the negative 23. Okay, again, it's a decimal, and because it's negative, we're actually kind of doing a little bit backwards kind of thing, and so it will be negative 23 because it doesn't have as many decimal points, which makes it actually a bigger number. Okay, if you need to kind of stop and think about that for a second, please do, but we're dealing with decimal points, and it's a really small number between 0 and 1. All right, let's look at number 3. It says point A on the zoomed in number line describes the wavelength of a certain X-ray in meters. So I'm going to label that to kind of remind me. This is X-ray. Cool. All right, and it says write the wavelength of the X-ray as a multiple power of 10, and write the wavelength as a decimal. So go ahead and pause, answer that question, and then come back to me. All right, so notice how I labeled my number line, okay? And I noticed that how it goes from 6 times 10 to the negative 12 all the way to 7 times 10 to the negative 12. So this is 6.1, 6.2, 6.3, 4, 5, 6, 7, 8, 9. And all of these are negative 12s because it goes from negative 12 all the way up to negative 12. So X-ray is point A. So we want to go ahead and we want to figure out what this point is here. That point is 6.1 times 10 to the negative 12. So then, okay, so that's our number, right? And we need to go ahead and we need to write it as a decimal. So I know that there's going to be 12 decimal places. The 6 is going to take one of them. Okay, so I'm going to have it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 with the 1 at the end. Okay, and this is the decimal, and it's also meters, right? If we wanted to go ahead and label everything, everything's in meters. So this is the powers of 10 number, and this is also the decimal number. So notice how today we were talking about 10 to the negative 5 and then also 10 to the negative 4 and which one would be bigger or which one would be smaller. So remember, if it's 10 to the negative 5, you have more decimal places. So that's going to be a smaller number compared to something 10 to the negative 4. You have not as many decimal places, and so that would be a larger number. So kind of keep this in mind while we're working through all of these. Go ahead and turn to page 131. Read the I can statements for lesson 10 and 11. 10 is, I can write a larger number as a multiple of power of 10. I can plot a multiple of power of 10 on such a number line. And I can subdivide and label a number line between 0 and the power of 10 with a positive exponent into 10 equal intervals. Lesson 11 was the negative side of the exponent. So I can write a small number as a multiple of power of 10. I can plot a multiple of power of 10 on such a number line. And I can subdivide and label the number line between 0 and the power of 10 with a negative exponent into 10 equal intervals. Give yourself sentences about these and also give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. Today, unfortunately, because we did 2 lessons, we also have 2 practice problems. So we're doing practice problems 10 and 11 for today. So make sure you go ahead and do those. I hope you have a good day. Thanks. Bye.